Good day, ladies and gentlemen. You're welcome to another exciting class with Mr. Simplicity. I want to quickly appreciate you guys so far. You have been so wonderful following us on this channel. And in case you are new to this channel, please do well to hit the subscribe button and leave a comment in the comment section below. Okay, I remain Mr. Simplicity. I think I've said that before. Okay, don't worry, I've said that before. Don't bother. So let's dive into the video of today. Today we are going to be looking at the third rule of differentiation. We have looked at the first rule, which is the general rule or polynomial rule. We have looked at the second rule, which is the product rule. And today we are looking at the quotient rule. The quotient rule. What did it say? The quotient rule says that if y is equals to u over v, where u and v are functions of x, then dy over dx is v du over dx minus u dv over dx all over v squared. If you look at product rule, there is a connection. In the product rule, this is plus and we don't have a denominator. So the quotient rule, you change the plus in product to minus and you divide everything by v squared. Okay, with that you can relate them and easily remember them. Okay, so the procedure remains the same. Whenever you are given a quotient problem, as you can see, a quotient problem has to do with a fraction that contains two functions of x, one at the numerator, one at the denominator. Whenever we are given a problem on that, what we need to do is to pick our u as we did for product and differentiate it, pick our v as well, differentiate it, and substitute into the formula. When you substitute into the formula, the problem is solved. That means you are done differentiating. But as usual, you can't leave it like that. You have to simplify it. Okay? So let's look at some examples. Let's make it more practical. The first example we'll be looking at today says, find dy dx if y is equals to x squared over 2x squared minus 1. So both are polynomial function. So we can start by writing our formula. Dy over dx is equal to v du over dx minus u dv over dx all over v squared. Okay, having done this, we can take our u, let u be equal to, according to the rule, u is the numerator. So this is my u and this is my v. So if I take my u, I have x squared plus 3, differentiate it, you have du dx, which will give you 2 times x, give us 2x. And differentiate 3 is 0. Okay? Then v is equal to 2x squared minus 1. 2x squared minus 1. So we differentiate it, we have the v over dx. And if we differentiate that, we have 2 times 2x, 4x. Differentiate minus 1 is 0. So now we can substitute into our formula. Dy over dx will now be v, that's 2x squared minus 1, du dx, that's 2x, considering our formula, minus u is x squared plus 3, then dv dx there is 4x, all over v squared. Our v is 2x squared minus 1 all squared. Okay, so this is our answer, just that we have to simplify. In simplifying, we should open this bracket. So 2x times 2x squared will give us 4x cubed, minus 1 times 2x will give us minus 2x. Okay, so this minus sign is going to change anything like the sign of whatever I get in expanding this. So x squared times 4x will give us 4x squared negative 4x cubed rather, give us 4x cubed. Then 3 times 4x will give us 12x times the minus 1. That's minus 12x all over 2x squared minus 1 all squared. 4x cubed is gone. So what I have left is minus 2x minus 12x. That will give us minus 14x all over 2x squared minus 1 all squared. These are our answer. Okay, the next question for today says we should find dy dx if y is equal to x cubed minus 2x raised to the power minus 4 over 2 bracket x squared minus x. So in this question, this is a fraction, so we can apply quotient rule. But before we apply product rule, we can open the bracket as the denominator, then we'll work with whatever we get. If I do that, y will become x cubed minus 2x raised to the power minus 4 all over 2 times x squared is 2x squared and 2 times x is 2x. Okay, this is my u, this is my v. My formula says dy over dx is equal to v du dx minus u dv dx all over v squared. So as usual, we're going to take our u and differentiate it. So let u be equal to the numerator x cubed minus 2x raised to the power minus 4. Then du over dx, as usual, polynomial differentiation. 3 times x will give us 3x. 3 minus 1 is 2. Minus 4 times minus 2 will give us plus 8x. Then minus 4 minus 1 will give us minus 5. Okay? Then we take our v. V is equal to the denominator 2x squared minus 2x. Then dv dx will be equal to 2 times 2, 4x. Differentiate 2x, you have minus 2. So now let's substitute into the formula. Substituting into the formula, v is that's dy over dx is now equal to v, which is 2x squared minus 2x times du dx, which is 3x squared plus 8x raised to the power minus 5 minus u is x cubed minus 2x raised to the power minus 4 times dv dx. dv dx is 4x minus 2. So all over v squared. 2x squared minus 2x all squared. So now we'll need to simplify by opening up the brackets. So if we expand this, we're going to have 2x squared times 3x squared. Let me show you what exactly is happening here. The first we multiply this. The first again we multiply this. Then the second we multiply this. The second again we multiply this. That's how you expand. Okay? So when you start first here times first here, that's 2x squared times 3x squared. In multiplying, 2 times 3, 6. X squared times x squared, take the x, add the power, 2 plus 2, 4. That's how you multiply polynomial. Excuse me. Okay? Then if we do the second one, 2x squared times 8 raised to the power minus 5. We have 2x squared times 8 raised to the power x raised to the power minus 5. The same thing. 2 times 8, 16. X squared times x, take the common base, add the power. That will be 2 minus 5. That will be minus 3. So this is how you'll be doing them one by one. When you are through with the first one, you come to the second one, multiply again. So for the second one, let me also show it before we go fully into the multiplication. The second one, we have minus 2x times 3x squared. Minus 2 times 3 is minus 6. X times x squared will give us x cubed, which means power 1 plus 2, 3. Okay? minus 2x again times 8x raised to power minus 5. Minus 2 times 8 will give us minus 16. This is 1. So x times x raised to power minus 5 will give us, take the common base, add the power. 1 plus minus 5 is minus 4. So this is what happened when I expand. Okay, so let's do it in the main question. So coming back to the question, we have now 2x squared times 3x squared, 6x raised to power 4. You know we got that now. 2x squared times 8x raised to power minus 5. We have plus 16x raised to power minus 3. Minus 2x times 3x squared will give us minus 6x cubed. Minus 2x times 8x raised to power minus 5 will give us minus 16x raised to power minus 4. Okay, so we're going to do the same thing here. This will multiply the first, this will multiply the second, this will multiply the first, this will multiply the second. Okay, so if we follow the same procedure, we are going to have x cubed times 4x squared. So that will be, here is coefficient 1. So 1 times 4 is 4. X cubed times x is x raised to power 4. And remember, I said whenever there is minus outside, if you have a positive outside, that will be negative, minus 4x raised to power 4. Okay? We do the same thing, first and the second. X cubed times minus 2x will give us minus 2x cubed. But I'm going to write plus 2x cubed. Okay? Then we go to the second term, minus 2x times 4x will give us minus 8x raised to power minus 3 when you add the power. So minus 8x raised to power minus 3 become plus 8x raised to power minus 3. Then we come to the last one, minus 2x times minus 2, that's plus 4x raised to power minus 4. But the minus sign makes it minus 4x raised to power minus 4. So with this in mind, all over 2x squared minus 2x all squared. So let's see what we have finally. Collecting like 10. X raised to power 4, x raised to power 4 is like 10. 6 minus 4 is 2x raised to power 4. Okay? X raised to power 3, x raised to power 3 is like 10. Minus 6 plus 2 is minus 4. Is there any square? Is there any x? So the next is x raised to power minus 3. So x raised to power minus 3, x raised to power minus 3. 16 plus 8 is 24. So I have plus 24 x raised to power minus 3. Then we have x raised to power minus 4. Minus 16 minus 4 will give us minus 20 x raised to power minus 4 all over 2x squared minus 2x all squared. You can leave our answer at this point. Okay, let's look at this next example of quotient rule. It says find the y dx if y is equal to exponential x over sine x. Okay, so write your formula. Formula says dy over dx is v du dx minus u dv dx all over v square. Then we take our u as usual. This is our u and this is our v. Let u be exponential x. So the du over dx will be equal to, from our table, exponential remain the same. Okay? Then we take our v is sine x. So if we differentiate it, dv dx is equal to, when you differentiate sine from our table, it gives us cos x. Okay? So with that in mind, we can substitute into the formula now. So if we substitute, we have dy over dx to become v, which is sine x, du dx, which is exponential x, minus u, exponential x, dv dx, cos x, all over v squared, sine x squared. Okay, so we are done differentiating. We want to simplify to get our answer. So I'm simplifying. Sine x times exponential x will give us exponential x sine x minus exponential x times cos x will give us exponential x cos x, all over sine x all square is the same thing as sine square x. So exponential is common at the numerator. If I bring it out, I have sine x minus cos x left, all over sine square x. So these are final answer for this problem.